In this video, we're going to take a look at section 5.4 on complex fractions. A complex fraction is a fraction that has fractions in either the numerator, denominator, or both. So that was a lot of use of the word fraction there, so I apologize if that's a confusing definition. Essentially, you can think of it as a fraction inside of a fraction. So if you have fractions inside of fractions, it's a complex fraction, which we don't like. We don't want to have complex fractions. So to simplify a complex fraction, we want to turn it into an ordinary fraction. We don't want fractions inside of fractions. To accomplish that, you'll first find the LCM of all the denominators on the top and bottom of the big fraction. Then you will multiply the LCM to the top and bottom of the big fraction, and then simplify. And what should happen is all the fractions on top should go away, all the fractions on the bottom should go away, and so you'll just end up with an ordinary fraction as an answer most of the time. All right, and reduce your answer if possible. So anytime you have an answer that's a fraction, you want to try to reduce it. All right, let's take a look at some examples. That's all I really have for this video, is just there's the definition for a complex fraction, here's how we deal with it, and then it's just a bunch of examples. So these are just numbers, so this is a pretty straightforward example here. We have 1/4 plus 2/5 on top over 4/9 minus 1/3. So it's a complex fraction because we have fractions in the numerator, we have fractions in the denominator, so fractions inside of fractions. To get rid of the I don't want to say get rid of the fractions here, but to make it so it's not a complex fraction, we'll follow the steps that we just saw on the previous screen. So let's find the LCM. Well, first we're supposed to factor all the denominators, but these are just numbers, so we're not going to bother factoring them. What we want to do is find the LCM of all the denominators on the top and bottom of this big fraction. So we have 4, 5, 9, and 3. We have to think of all 4 of those. We want to find the common denominator for 4, 5, 9, and 3. Or the LCM of 4, 5, 9, and 3, which is going to be the smallest number that can be divided by 4 and divided by 5 and divided by 9 and divided by 3. All right, so that's a pretty tough one. Trying to think what that might be off the top of my head. I don't think I know. I was thinking 45, and that almost works except for 4. All right, so we need something that also works with 4. Let's see, 72 doesn't work, I don't think, because of the 5. This is going to be kind of a big number. It might be, no, that doesn't work either. I was going to say 120, but that doesn't work with 9. I don't think 90 works because I don't think 4 divides into 90 either. 180? 180 might work. 180 is divisible by 9. 180, I believe, is divisible by 4. Definitely divisible by 5. And if it's divisible by 9, it's divisible by 3. So I'm going to go with 180. I don't know if that's the smallest number that can be divided by each of these, but it works. It is a common multiple, if not the least common multiple. I can't think of anything smaller that might work. Like 150, 160. I can't think of anything smaller that might work. So let's go with 180, see what happens. All right, so we'll multiply. So if our LCM is 180, we're going to multiply it to the top of the big fraction and the bottom of the big fraction, right? We're balancing it out by multiplying it to the top and to the bottom. All right, and then you'll distribute. And what should happen is that the fractions should get canceled out, right? So 180 times 1/4, that's just 180 divided by 4. And so if we wanted to find out what is 4 divided into 180, we could do that over here, or you could use a calculator. 4 goes into 18 4 times, you get 16 from that. Subtract, you have 2 left over. Bring down the 0. 4 goes into 25 times, so we get 45. So 45 plus, here what's going to happen is the 5 will divide into the 180. So we get 5 divided into 180. 5 goes into 180 3 times, we'll get 15 from that. Bring the 3 down, 3 left over, I should say, and then bring the 0 down. 5 goes into 36 times, so we'll get 36. But then we have to multiply by 2. So you divide by 5, that's how we got 36. then you multiply by 2. That's going to give us 72. Right. Over this one, 180 divided by 9 is going to be 20. 20 times 4 is going to give me 80. Minus 180 divided by 3 is going to be 60. All right. And then we simplify. Right, so we'll add these together. I wish I should be able to do that without having to do it like this. I should be able to do it in my head, but I don't know. I'm feeling like I can't think right now. So that's going to be 117 over 20. And so I think 180 is the least common multiple, because if it wasn't, if we picked something that was bigger than it needed to be, then this would be reducible, but this doesn't reduce, right? 117 is not going to cancel out with anything in the 20. So since that doesn't reduce, I'm pretty confident that we did find the least common multiple. So we get 117 over 20. Not the greatest answer. Again, it's still a fraction, but it's not complex. We don't have fractions inside of fractions anymore. All right. So for finding the least common multiple, again, I was trying to do it off the top of my head. Something you might try to do if you can't think of 180, if you're not coming up with that, is to make a list of the multiples of these numbers until you find one that's common to all 4 of them. And it's going to take a while, right? It's 180. So you do 4, 8, 12, go forward like that. 5, 10, 15, 9, 18, 27, 3, 6, 9, 12, dot, dot, dot. And eventually you would find 180 on all 4 of these lists. And it should be the first number that's common to all 4 of them. That'd be another way to find that least common multiple. So hopefully the one you have on the homework won't be quite this bad. Or if it is, hopefully it's the only one that's like this. Because the next examples are going to involve variables, which surprisingly is going to be easier to find the LCM if you know what to do. All right, so let's look at another example. All right, so this one's really easy. So first step would be to factor the denominators, but there's nothing to factor here. And then we need to find the LCM. And I'm having trouble remembering. Was that also in the first step, or was there 4 steps? Find the LCM. Okay, so step 1 is to find the LCM. And remember, to find an LCM, you have to have everything factored. That goes back to what we learned in 5.2. So that's not explicitly mentioned in my steps, but finding the LCM, you have to factor things first. But this cannot be factored. So we just jump right into finding the LCM, which is the common denominator, which in this problem is the only denominator, right? X is the only denominator on the top of this fraction. X is the only denominator on the bottom. And so the common denominator is going to be X. It's the only factor, right? And so X, raise it to the highest power that occurs. It's to the first power in both of these cases. Multiply, so this is step 2, multiply that common denominator to the top and bottom of your big fraction. All right, so again, that's balanced out. We'll distribute the X in the numerator. And what's going to happen when X gets multiplied to this first fraction is the X's are going to cancel out. And we'll have 1 left over. All right, so the X's cancel out and we'll have a 1 left over. Plus, we'll have 3 times X as our second term. Do the same thing for the denominator, and pretty much the same story here. X times 1 over X, the X's will cancel out. Think of this as X over 1, right? The X's cancel out, and we'll have 1 over 1 left, which is going to be 1, minus 7 times X, which is just going to be 7X, and that's it. All right, you could try to simplify or reduce, but these aren't like terms, so you can't combine them together. And nothing reduces here because nothing factors, right? You have to be able to factor in order to reduce. And since these don't factor and they don't share anything in common, nothing can be canceled out. Now you might say, wait, they share the X's in common here, but again, these are terms and you cannot cancel out terms, right? It has to be a factor that's shared in common that you can cancel out. And these share no factors in common because the only factor here is 1 plus 3X. The only factor here is 1 minus 7X. They're not the same, so they don't cancel out. All right, so that's, like I said, a lot easier when you're dealing with a variable than when you're dealing with numbers. Same thing here, right? So the first step is to find the LCM. I guess I'll do that over here since I don't really have room up here. LCM, we have X, Z, X, and Z. So again, we take each factor that occurs. X is one of the factors that we have here. And Z is another factor that we have here. And we raise each one to the highest power that occurs, but all of these factors are to the first power, so these will stay to the first power as well. So that's the LCM, is just xz. The second step is to multiply that LCM to the top and bottom of the big fraction. And then the third step is to simplify. So we will distribute. Think of this as being over 1. When this gets multiplied to the first fraction, what's going to happen there is you'll have 4 over x times xz over 1. And the x's are going to cancel each other out because you have an x on the bottom, that's a factor because it's by itself. And you have an x on top, that's a factor because it's being multiplied to the z. So those x's cancel out. And then you multiply across, and what you'll have is 4z over 1, right? Which we can just write as 4z, so it's not a fraction anymore. Right? And that's the whole point of this exercise, is to rewrite this so there's no fractions on top and no fractions on the bottom. Right? Plus, and so I wrote this one out so you can kind of see in detail what's happening there mathematically. But most students, most people try to get to the point where they can just kind of work this out mentally. So let's try to do that here. So this will get multiplied to 2 over z. The z's are going to cancel out. So what are we going to have left? If the z's go away, we'll have 2x on top over 1, which we can just write as 2x. And again, the fraction goes away. All right, let's try to do the bottom one. Maybe if you would like to practice it yourself, pause the video for right now and see what you think the denominator should look like. And then resume the video to check to see if you had the right idea. Right. So think of this as being over 1. When you multiply this to the first fraction, the x's cancel out and you'll have 7z left over 1, which you don't have to write, minus, here the z's cancel out and we'll have 8x left over. So this is what you should get for the denominator. And that's the end, right? Now we could factor out a 2 from the numerator, and that would leave me with 2z plus x, but that still doesn't match up what's in the denominator, so nothing cancels out. It's not going to reduce, which is going to be the case 99% of the time, but it's still something you should look into. You know, can this factor? If so, will it lead to something getting canceled out? And if not, then you just skip it, right? You just don't bother with it. But if something could cancel out, you need to go ahead and do that. All right, let's take a look at another example. So again, here, there's nothing to factor. So to find the LCM, you want to factor your denominators, but these are already too simple to factor. So they are their own factors. The factor here is y plus 3 because it's the only thing there and it can't be broken down into anything else. The factor here is y minus 5. Same thing for these denominators here. So to find the LCM, you take each factor that occurs. Well, y plus 3 is one factor that we see down here in these denominators, and y minus 5 is another factor. Now here the common denominator is a little bit more complicated looking, but this problem actually I feel is even easier than the last one that we did for seeing what cancels out and what's left over. So we're going to multiply this, so that's the LCM, raise each one to the highest power that occurs. It's all to the first power. We'll multiply the LCM to the top and bottom of this big fraction. Okay, now when I said it's even easier, maybe I'm exaggerating a little bit because this is a pretty intimidating looking expression, right? But it's not that bad. Just be careful not to multiply it out. That's a mistake I'll see students make. They foil here. You don't want to do that. You want to leave this factored because you need factors for things to cancel out. And that's the whole point of what we're doing here, is to get things to cancel out. Right? So we'll multiply this to the top and bottom. Think of it as over 1. Distribute it. And when I'm in class, I actually physically cover up the thing that cancels out. So it makes it easier for students to see. I can't really do that here. I guess I could, well, no, I can't really do it. I guess I could do it temporarily. I don't want to mark on this because a fresh copy of this gets multiplied to the second fraction. And so I don't want to mark on this original copy here because then you might think it's gone for good, and it's not. So, but I'll do it temporarily. So when this multiplies to this, what's going to cancel out are the y plus 3's. And what's going to be left over is 7 times y minus 5. Right? Now I'm going to undo that crossing out because I need a fresh copy of this to get multiplied to the second fraction. So let's undo that. Right, but these are what's going to cancel out. And then what's going to be left over is the 7 times the y minus 5 because the y plus 3 went away. And that's it. And it's over 1, which means we can drop the 1 and it's not a fraction anymore. plus, same thing's going to happen here. We'll have y minus 5 cancels out with the y minus 5. What's going to be left over is 6 times y plus 3 over 1, which again we can just drop. So 6 times y plus 3. That's what we'll have left over there. All right. On the bottom, same thing's going to happen here. So again, why don't you pause the video, see if you can simplify the denominator to this point. I mean, there's more we're going to have to do here in just a second, but just get to this point here and then resume the video to see if you got the right result. All right, so what should happen here is the y minus 5 is going to cancel out. Sorry, that was kind of a bad crossing out there. And what's going to be left over is 7 times y plus 3. All right, so we'll have 7 times y plus 3 here, minus, here the y plus 3's are going to cancel out, and we'll have 8 times y minus 5 left over. So 8 times y minus 5. All right. And so it's not a complex fraction anymore. But then we want to simplify this. Now, you might think, oh, the 7's cancel out because it looks like it's a factor. It is being multiplied to the y minus 5, but because of this plus sign here, that makes this whole thing a term, and you cannot cancel out terms or parts of terms. So the 7 does not actually cancel out here. Same thing with the y minus 5 here. It doesn't cancel out with the y minus 5 here because these two things are parts of terms. So you can't cancel them out. The only way you can cancel things out is to multiply this out, combine like terms, and then try to factor it as a whole, right? So, because this is only, just this term is factored. The whole expression on top is not factored, right? Because we have this extra term over here. What you need to do is factor the expression as a whole, not just part of it, right? So to factor it as a whole, we're going to have to actually distribute the 7 into the parentheses here, and the 6 into the parentheses here, combine like terms, and then we can try to factor the expression as a whole and see if something cancels out. So we'll have 7y minus 35, that's what we get from that, plus 6y plus 18. So that's what we get on top. On the bottom, we will have, distributing, 7y plus 21. And here, when we distribute the 8, the negative has to go with it, so we'll get negative 8y plus 40. Combine like terms, and you'll get 13y, and that doesn't look very promising for factoring, minus, what is that going to be, 17? Yeah, I think that'll be 17. Minus 17. That doesn't factor. And so if it doesn't factor, it's probably not going to cancel out. Here we'll get 7y minus 8y, which is negative y, and then 21 plus 40, which is 61. So yeah, this is not reducing. Right? You can't cancel out the y's here because they're terms. The only way you could cancel this out is if you could factor it, and it doesn't factor, so it's not going to reduce. All right. Okay, so let's take a look. I have a couple more examples here. They get a little bit more complex. Finally, we're looking at some examples where we have to do some factoring. And so before we can get started on this problem, we'll have to factor these denominators. We have to factor them for two reasons. One, so that we can find the LCM, because to find the LCM, you need to know what the factors are. But two, we want to have this factored so that we can cancel things out, because we want to get rid of this. So I'm looking to have stuff cancel out, and if you want things to cancel out, you need to know what the factors are. So we need to factor it. We need to rewrite the problem with these denominators factored. So all of these denominators here need to be factored. Thankfully, they're the easier type of factoring. They're going to go easy on you with how difficult the factoring is in this section because the problems are pretty complex, so they don't want to pile on with difficult things to factor. These are easy to factor because in every case, a is equal to 1. And when I say a, I'm not talking about the variable a. I'm talking about the coefficient in front of the square term, right? This is a 1, which means we can factor by finding two numbers that multiply to c and add to b. So two numbers that multiply to 16 and add to 10 would be 8 and 2. Right? 8 times 2 is 16. 8 plus 2 is 10. The numerator there will still be a 1. Plus, we'll do the same thing for the second fraction. Two numbers that multiply to negative 12 and add to negative 4 would be negative 6 and positive 2. and there'll still be a 1 on top here. All right. That whole thing is over. We'll have 1 over here, and then we'll have plus sign 1 over here. Okay. So now we'll factor this bottom one here, the left, how do you want to say it? The bottom left corner. Two numbers that multiply to negative 8. Sorry, why did I say 8? Two numbers that multiply to negative 48 and add to 2. That's going to be positive 8 and negative 6. Right, so that's how that one's going to factor. Here we need two numbers that multiply to 8 and add to 9. That's going to be positive 8 and positive 1, which I wasn't really expecting that. That a plus 1 is going to make things even more complicated than they already are. So we factor all the denominators. We rewrite the problem with those factors. Now we can find the LCM, which I'm going to write up here, hopefully out of the way of everything else we're going to have to do. You take each factor that occurs. We have a plus 8 is one factor. We have a plus 2 is another factor. We have a lot of factors here. We have a minus 6 as another factor. And like I said, I wasn't quite I thought we were going to have 3 factors, but they made us have a 4th one here. We're going to have a plus 1. So looking at all these denominators, all the factors that I can find here are these 4. Right? Some of them are repeated, some of them aren't. But you take each factor that you can find and put it in your LCM. Then raise each one to the highest power that occurs. I'm going to keep saying that even though it never applies in section 5.4. They're all to the first power. So all of these will stay to the first power. So there's my LCM. That's the thing that I want to multiply to the top and bottom of this big fraction. So I'm going to multiply, it's a lot to write out, but a plus 8 times a plus 2 times a minus 6 times a plus 1. Multiply that to the top. And I'm going to multiply the same thing to the bottom. A plus 8, a plus 2, a minus 6, a plus 1. And it's already starting to get laggy on me here. All right, so now we're going to do what we did before. We're going to simplify by multiplying this and distributing it to the numerator and to the denominator. And what should happen is my fractions should go away. Things should cancel out. And so let's write the result up here. So I'll continue up here where I think I'll have enough room. And then we'll have to continue on another page to finish simplifying this. So what's going to happen here, so again, let's see if we can do this mentally. Well, I'll go ahead and cross it out temporarily. What's going to cancel out here is the a plus 8 will cancel out, and the a plus 2 will cancel out. And so that denominator goes away, so it won't be a fraction anymore. And on top, what's left over is 1 times a minus 6 times a plus 1. Well, if you're going to multiply by 1, the 1 just goes away, right? It just disappears because it doesn't change anything. So we're just going to have a plus, sorry, I said the wrong thing. We're going to have a minus 6 times a plus 1 left over, right? These two factors go away. Here's the two factors that'll be left over. Multiply by 1, it'll stay the same, right? So let me undo the crossing out that I did. Right. So for the first fraction, what's going to be left over is an a minus 6 times an a plus 1. All right. Plus, for the second fraction, what's going to cancel out is an a minus 6 will cancel out, and an a plus 2 will cancel out. So what we're going to have left over is a plus 8 times a plus 1 times 1, which again, the 1 just goes away. So we just get a plus 8 times a plus 1 left over there. So again, let me undo the crossing out there. And so we'll have a plus 8 times a plus 1. All right. So why don't you pause the video and see if you can figure out what the denominator should look like for this problem, and then resume the video to see if you had the right result. All right. So what you should get here on the bottom, a plus 8 and a minus 6 cancel out. So what I'll have left over is a plus 2 times a plus 1. All right, so a plus 2 times a plus 1. All right, plus, because again, there's a plus sign here, a plus 8 cancels out, a plus 1 cancels out, so what we'll have left over is a plus 2 times a minus 6. Try that again. A, okay. Let's try that again. A minus 6. All right. So it's not a complex fraction anymore. That is the main thing we're trying to accomplish, but we don't want to leave it in this kind of a mess. We want to simplify it. And again, you can't cancel things out here because these things are terms because they're being added to each other. So what we'll have to do is multiply this out by FOIL. We'll have to FOIL this out, do the same thing on the bottom two here, combine like terms, and then see if we can factor it to get it to reduce, right? So I'm going to need more room. So I'm trying to remember, how did I do this before? I did it on the last video, I think. So I need to copy and paste didn't work, but I think I can snap a picture here. Let's see. Capture part of the screen. Yeah, that's what I want to do. Okay. Capture part of the screen. We'll capture this part. So here's where we're leaving off from the work we've done so far. We'll put this on a new page. All right. And then we can move this up in the corner. Perfect. And that works pretty easily, pretty nicely. Okay. Sorry, I'm talking to myself. All right. So let's go ahead and continue this problem from here. All right. So as I mentioned, we're going to FOIL. So let's go ahead and do that first. And in fact, to save some writing, we can just kind of work this out just above and below where the problem currently is. So a minus 6 times a plus 1, if we FOIL, we'll take first, which is a times a, which will be a squared. And then we'll have a times 1, that's the outer terms, which will be a. Negative 6 times a will be negative 6a, and negative 6 times 1 will be negative 6. We'll do the same thing with this one. We'll have a squared plus a plus 8a plus 8. And we're going to add those two sets of expressions together. So when we combine like terms, we'll get a squared plus a squared, which will be 2a squared. We'll have this is minus 5a, and this is 9a. So adding those together, we'll get positive 4a. And then we'll have negative 6 plus 8, which will be positive 2. All right, so that's what we get for the numerator. So again, pause the video, see if you can work out what the denominator should look like, and then resume the video to see if you have the right result. What you should get is a squared plus a plus 2a plus 2 from the first set. From the second set, you should get a squared minus 6a plus 2a minus 12. Then we're going to add those two things together because we have a plus sign here. This is going to be 3a. This is going to be negative 4a. So we'll have 2a squared again, because a squared plus a squared gives me 2a squared. 3a minus 4a would be negative a, and then 2 minus 12 is going to be negative 10. All right, so now we have to try to factor this to see if it can be reduced. You cannot cancel out terms, so again, the 2a squareds don't cancel out, but we could try to factor this. So the numerator, we can factor by factoring out a 2. It leaves me with a squared plus 2a plus 1, which can then be factored. So maybe I should just write it down here. That can be factored. Two numbers that multiply to 1 and add to 2 would be 1 and 1. So it actually does factor. Factors is a plus 1 times a plus 1. So we have some factors here. So there is a chance that maybe this could be reduced. To factor the denominator, we'll have to do the AC method. So let's just do that over here. We'll have a times c is going to be 2 times negative 10, which is negative 20. And b is equal to negative 1. So two numbers that multiply to negative 20 and add to negative 1 would be negative 5 and positive 4. So we're going to rewrite the middle term. So again, we don't get to cheat here and just jump right to the factoring, to the answer. We have to actually do the factor by grouping process, right? So we're going to split the middle term up. We're going to write that as, I'm trying to think where to put this at, 2a squared minus 5a plus 4a minus 10, right? We're rewriting negative a as negative 5a plus 4a. And then we're going to group. So we do 2a squared minus 5a as our first group, plus 4a minus 10 as our second group. We factor out the a, we get 2a minus 5. Here we factor out a 2, we get 2a minus 5. And so this will factor as 2a minus 5 times a plus 2. So they both factor quite nicely, but after we factor, we see nothing cancels out. So it really can feel like, oh, that was a big fat waste of time because nothing canceled out. I spent all that time factoring it and for what? But it's important to check because every once in a while you'll get something that does actually cancel out, right? So you can either leave it like this, leave it factored. I hope Math Excel would count that as correct. Or you could just leave it like this, unfactored, right? Because it doesn't reduce anyways. All right. One more example. All right. I thought this was going to be a short video, but I'm already past the 30-minute mark. So I think this one's going to go a little bit more smoothly for us. So again, we have to factor first to find the LCM and to also get things to cancel out. So z squared minus 16 can be factored. And this is the a squared minus b squared formula, right? So remember this one, a squared minus b squared. Factors as a plus b times a minus b. And so this will factor as z plus 4, z minus 4. So I know I'm kind of going through that pretty quickly, really just kind of assuming that you can figure that out, because we've seen it so many times. We saw it several times in chapter 4, and we've seen it a lot in chapter 5. So by now, I'm hoping that you're getting the hang of that type of factoring. Right? Over 5 times z plus 4, which doesn't factor, which means z plus 4 is the factor in this denominator. That whole thing is over, again, 3 over the same thing. This will factor as z plus 4 times z minus 4 minus, this time it's 5. Everything's the same, which is really weird, except for this one last thing here. This is z minus 4. This is definitely a weird setup to a problem. All right, so now we can find the LCM. We take every factor that we can find in the denominators here. So we have z plus 4, right? That's one of the factors. I see it in several places. And we have z minus 4, which we see in several places. And that's it. Those are the only two factors that occur in all of my denominators. So we're going to multiply that to the top and bottom of this big fraction. Z plus 4, z minus 4 to the top. Z plus 4, z minus 4 to the bottom. We'll distribute. Sorry, that was kind of a bad drawing for an arrow. What's going to cancel out when these multiply together? Think of this as being over 1. Everything, right? The entire denominator cancels out with the entire LCM. Z plus 4s cancel out. The z minus 4s cancel out. So what am I going to be left with? I'll be left with just the number 3 because everything else got canceled out. So we'll just have a 3 left over from that first fraction. So I have 3 here minus, for the second fraction, just the z plus 4 cancels out. So I'm going to have a 5 times z minus 4 left over. So 5 times z minus 4. All right. On the bottom here, we're going to have a similar experience. If you want, pause the video and see if you can simplify the denominator, and then resume it to see if you got the right result. Think of this as over 1. We're going to distribute here. And again, for the first fraction, everything cancels out. Z plus 4, z minus 4 both cancel out. We just have a 3 left over, just like we saw happen in the numerator. So we'll just have a 3 minus 5 times, what's going to happen in this case is the z minus 4s are going to cancel out. So we'll have 5 times z plus 4 left over. All right. And so this would be our initial result, and it's no longer a complex fraction, but we do want to try to simplify this and then maybe see if we can reduce it. So we're going to distribute the negative 5 into the parentheses here for both of these. So let's go ahead and continue up here, I guess. So we'll have 3 minus 5z plus 20, right? Because negative 5 times negative 4 make that a positive 20. And on the bottom, we're going to have 3 minus 5z minus 20, because negative 5 times positive 4 would make that a negative 20. We'll combine like terms, so we'll get 23 minus 5z on top, which doesn't factor, so it's not going to reduce. And on the bottom, we're going to have negative 17 minus 5z, which doesn't factor, so it's not going to reduce. So this would be my final answer. All right, so that concludes the video on section 5.4 on complex fractions.